Hello everyone, in this video we will discuss the memory based question of CSIR-NET and come to question number 13. Actually this is a part B question, and in given question A and N, B and R two bounded sequences in R, then which of the following option is true? We have this four option in which we have to find out correct one. Now come, that is, as we know that sequence A and sequence B and are bounded sequence in R. This implies that using definition of a bounded sequence, there exists n1 such that mode of an less than equals to k1, and there exists n2 such that mode of bn less than equals to k2. Now as we know that this inequality, that is mode of an plus minus 1 power n bn mode less than equals to mode of an plus mode of this. And now again simplify this, that is this less than equals to mode of an plus mode of bn. Now using 1 and 2, that is mode of an less than equals to k1 and mode of bn less than equals to k2. This implies that mode of this sequence less than equals to k1 plus k2. This implies that this sequence is bounded sequence, and in a real analysis we know that if a sequence is bounded, then its limit superior and limit inferior must exist. So using this result we can say that option A is incorrect, because in given option we have given that the limit superior of this may not exist, so this option incorrect. Now come to next option. For option B, in option B we have given that the limit superior of an plus minus 1 power n into bn equals to limit superior of an plus mode of limit superior of bn. Now for this option we take a counter example, that is an is equals to minus 1 power n plus 1 and bn is equals to 1. Now using these two sequences, an plus minus 1 power bn sequence convert to null sequence, and we know that limit superior of null sequence is 0, and using these sequences limit superior of an is equals to 1 and limit superior of bn is equals to 1. Now putting these values in a given option inequality, that is 0 equals to 1 plus mode 1. This implies that 0 is equals to 2, which is impossible. This implies that option B is incorrect. Now come to option C, and in option C we have given that this inequality. Now for this inequality we take counter example, that is we take a sequence an is equals to null sequence and sequence bn is equals to constant sequence, where constant is equals to -5. Now using these two sequence we have a limit superior of an is equals to 0 and limit superior of this constant sequence is equals to -5. Now using these two sequences, our sequence an plus minus 1 power n into bn sequence converted to minus 1 power n into -5. As we know that limit superior of this sequence, that is this sequence, is equals to 5. Now putting this value of this superior of sequences in this given inequality, we have 5 less than equals to 0 minus 5. This implies that 5 less than equals to -5. This is impossible. This implies that option C is again incorrect. Now come to option 1 is incorrect, option B incorrect, option C incorrect, so rest option, that is option D, is correct. Now come to from part C question. Actually fz is equals to 1 minus z into e power z plus z square upon 2, which further equals to 1 plus this series expansion. Now in question, which of the following are true? We have to find out true option from this 4 option. Now come to explanation. As fz is equals to 1 minus z into e power z plus z square upon 2, now apply product rule for differentiation. We get fz is equals to e power z plus z square upon 2 into 1 minus z square minus 1. This minus 1 cancel with plus 1, and we left f dash z is equals to minus z square into e power z plus z square upon 2. So our option B is correct. Now come to further option, equals to 1 plus summation of an into z power n where n is equals to 1 to infinity. We also written this form of fz is equals to this form, where fz is equals to a0 plus a1z plus a2z power 2 plus a3z power 3, where a0 is equals to 1. Now if fz is equals to this expression, we can say that an must be equals to fn at z is equals to 0 upon n factorial, where fn means nth derivative of f with respect to z. So using this result, we can find a1 and a2. That is, a1 is equals to f1 at z is equals to 0 upon 1 factorial. That is, f1 at z is equals to 0. Say equation 1. Similarly, a2, say equation 2. Now, as we know that f dash z is equals to minus z power 2 into e power z plus z square upon 2. So in this way, we also find f double derivative of with respect to z, that is equals to e power z plus z square upon 2 into minus 2z minus z square minus z cube. So f double derivative at z is equals to 0 is equals to 0. This implies that a2 is equals to 0, and similarly f derivative at z is equals to 0 is 0. This implies that a1 is equals to 0. From this two, this implies that a1 is equals to a2, which is equals to 0. This implies that a1 is equals to a2. So option A is correct. Now a3 is equals to f3 at z is equals to 0 upon 3 factorial. This implies that f3 at z is equals to 0 upon 6. As we know that f3 at z is equals to 0 is minus 2. This is exercise for you, and upon 6 this is equals to minus 1 upon 3, and so on. This implies that an belongs to semi-closed interval, that is minus infinity to 0 for every n belongs to set of natural number. This implies that option C is correct. Now for option D, summation of mod of an is equals to a mod of a2 plus mod of a3 up to so on. Now for this series we have to find out the value of an, that is equals to fn at z is equals to 0 upon n factorial. So using this result, a2 is equals to 0, a3 is equals to minus 1 upon 3, and a4 is equals to minus 1 upon 4, and an is equals to minus 1 upon n for every n belongs to set of natural number. So this implies that this series is equals to 1 upon 3 plus 1 upon 4 plus 1 upon 5 plus 1 upon 6 up to 1 upon an, and so on. This series equivalents to minus 1 upon n, where n is equals to 3 to infinity. And we know that by using a p-series test, this series is divergent. That is, this summation of mod of an, where n is equals to 2 to infinity, this series is a divergent series, and its sum always greater than 1. This implies that option D is incorrect. Now come to option again. Option A is correct, option B correct, option C correct, and option D incorrect.